Wind turbine noise means that people are more annoyed to it at lower levels. This graph shows, and it's kind of hard to read it here, but this is aircraft noise, road noise, and other types of transportation noise. And we see the curves for those right in here. If I want to say I'm only going to annoy 10% of the community, and I'm putting in a new highway, then I can set my criteria by coming up here. I follow 10% over, get the highway, come down. I can have levels at the homes of about 58 decibels. If I want to limit to the same percentage of people who are annoyed with wind turbines, I come over from 10, come to the wind turbine chart, and that ends up being about 35 decibels. The characteristic of wind turbine noise is such that people are more annoyed with it than they are other common community noise sources. Next slide. What is it that makes them more annoying? Well, one of the things that I routinely hear is that people are annoyed by this blade swish. This is a farm over in Wisconsin. It was one of the projects that I followed from conception to completion. And I'm at about 1,300 feet away from this turbine right here. And this up and down pattern, which is about once per second, is the blade swish. It's like the dripping water faucet. It isn't that it's so loud. We're talking 40, I got it looks about 40 dBA right through here, with the levels going up and down roughly about 5 to 10 dB. It isn't that it's so loud, it's that it's repetitive and it does not stop. Swish, swish, swish. If you get multiple turbines like we have in this area, you then begin to get competing swishes, as we see in this location right here, where they blend together, phasing in and phasing out. But this is one of the reasons why it is more annoying. Now, next slide. This is a sample I took inside the home of a person living 1,500 feet away from 3 turbines. This is inside the entry vestibule. So we're not outdoors anymore. We're inside the door with a wall protecting us. It's not as thick of a wall as we have for a home. It's a single wall, but it's enough to give a windbreak for people to come into their home. And what we're looking at here is, again, that blade swish rising and falling about once a second. And this is a characteristic of what people on this property basically put up with on an ongoing basis. Next slide. This is from a similar study done over in Britain, keeping St. Nicholas. This is 9 wind turbines. The nearest wind turbine is 3,000 feet away. We're on the second floor bedroom window, or second floor bedroom of a farmhouse. And inside the house, we're again picking up that blade swish. So I say this is one of the reasons why wind turbines are identified as being more annoying than other types of common community noises. Next slide. This is a model prediction using a single turbine at 1,000 feet. And what we're looking at here is what is the sound level. This is the upper line here is a GE 1.5 megawatt turbine, which is one of the workhorses of the industry. The blue line represents a study that was done by Delta, the Danish Electric Light and Technical Authority, where they took 41 wind turbines and averaged the spectrums together to come up with a composite spectrum. And we can see that the GE basically fits in very nicely with that spectrum. We can also see, however, this is frequency on the bottom. This is your infrasound down here. These are the audible frequencies. This curve right here is the threshold of audibility. Any sound that is above that line is audible to people, let's say 90% of the people, all but the least sensitive. What we're looking at then is outside in the yard, the wind turbines would be clearly audible at 1,000 feet. But inside the house, this is the calculated sound level inside the house, it would also be audible. One of the things I've heard quite often from the industry is that people inside the house, their house will not hear, if we set the criteria of 45 decibels outside, people inside the house will not be disturbed by the sound. Go to the next slide. That was actually looked at this summer, or this last summer. Asia Patterson and some of the other researchers that have done the European studies on annoyance took a look at what percentage of the people are annoyed at different sound levels outside the home. If we take the 45 LEQ that's being discussed here, that's basically this line right here. And what they found is that if it's 45 LEQ outside a home, that roughly 25 to 33% of all people will be annoyed with that sound inside their home. 10 to about 20% will be highly annoyed. Highly annoyed is a term that basically means you're ready to hire a lawyer. I kind of look at it this way. Annoyed is when you complain to your neighbors. Highly annoyed is when you decide you're going to do something about it. And so this is basically what we're looking at here is with 45 decibels outside, we find roughly 20-25% of the people somewhere between highly annoyed and annoyed, which is another reason why we need to be cautious about what we're saying outside. This is not an arbitrary calculated graph. This is responses from a large set of people who were involved in a very detailed study. So this is real response, not theoretical response. Next slide. We heard a little bit before about the 2009 World Health Organization guidelines. I would like to take just 1 second to point out that the 2009 guidelines were an entirely new set of research studies. Although they built upon what they had done in 1999, they had received a large grant of money, and so they had done all new sleep research. So it's not that this is new data. What they found is that if the sound levels outside a home are consistently less than 30, that there will be no substantial biological effects, no adverse health effects for people in the home. If it's 30 to 40, we begin to notice body movements, awakening, sleep disturbance, arousal. And while average effects may be modest for people who are young, children under 6 is generally the age group, chronically ill or elderly, those populations may be affected by levels in the 30 to 40 range. Next slide. When the sound levels